We are students of School of Quantitative Sciences, University of Utara, Malaysia, CAS, College of Arts and Sciences. So we're taking a course in Industrial Statistics known as Special Topics in Statistics, SQQS 3183. Our lecturer's name is Associate Prof. Bidin Yetim. So we are here to present a video on bootstrapping and resampling techniques. So here are my group members. I am Raji of matric number 222845. This is Ang.
I am Ang Jingshan, matric number 222761.
Nurasmaliza binti Bohari 221305 and Nusaliza binti Base 222541.
So now we are going to start the presentation now. So bear with us. These are the 4 topics we are going to present on. The first one is why resampling. It's going to be presented by Ang.
Yeah.
While the second topic is introduction to bootstrapping. It's going to be presented by Nurasmaliza binti Bohari. Then the third topic is why does bootstrapping work, stroke S+, and it's going to be presented by me. And the last topic is sampling and bootstrapping distribution. It's going to be presented by Shaliza binti Pasir. So bear with us.
So now I will discuss about the why resampling. First, we can quantify the uncertainty. As we can see that in here the histogram, we can quantify the uncertainty like by calculating the standard error and confidence interval. So we can see that we can use this as our second point performing the significant test. So while resampling and performing significant tests has a relationship. By using resampling, we can performing a significant test to make an inference of the population of the statistics. Thirdly, it is easy to perform. Why we can say that it is easy to perform? Because, for example, the bootstrap is just a concrete numbers that we can analyze using the tools that we usually familiar with. That is the histogram. The fourth point is assumption of traditional parametric tests do not match, such as when the small sample size with not normal distribution. So we can use the resampling. Lastly, we can address the question that cannot be answered by traditional parametric or non-parametric methods. For example, we can calculate the ratio of mean or medians. The resampling methods for calculating the mean, the ratio of mean, medians, and etc. are the same. So we don't need to find another new methods to calculate the mean and medians. Thank you.
Do you guys think there are other advantages apart from what Ang has said? Advantages of resampling methods?
For my opinion, bootstrapping has a greater accuracy than classical method.
It has greater accuracy than the classical methods. Okay. What other advantage?
Maybe a promote understanding.
Okay.
Because it is a easy method, right?
Okay. What about you?
My opinion is favor assumption, no need normal or large sample size.
Okay, no need to have normal or a large sample, which means we can use if the data is abnormal or if it is fairly normal, not perfectly normal, or with small number of sample size, right? Okay. What other advantages?
I think generality, do not new formula for each statistic.
Oh, okay, we don't need to have new formula for calculating it. Okay, that's all.
In statistics, bootstrapping can refer to any test or metric with replacement. The objective of bootstrapping is to determine the value of parameter of population. Next, let's move to the procedure of bootstrapping. First is we create hundreds of sample by sampling with replacement from the original sample. Each resample must be in the same size as the original sample. Sampling with replacement means that the process of putting back the original sample before withdrawing the next observation. This process can be done after we randomly draw an observation from the original sample. If we sample without replacement, we will get the same set of number we start with. Second process is calculate the bootstrapping distribution. It depends on what we want to find, whether mean, standard deviation, and so on. And lastly is use the bootstrapping distribution to get the information about the shape, the center and spread of the sampling distribution.
What bootstrap standard error of a statistic?
A bootstrap standard error of statistic is the standard deviation of the bootstrap distribution of that statistic.
So the formula is where B is the number of resamples and X bar star is the mean value of an individual resample.
So this is the formula.
Yeah, this is the formula for standard error bootstrap.
So I'm here to present on why does bootstrapping work and S+. So actually S+ is just a programming language. It's a programming software that is used in statistical analysis, and it can be used to generate random numbers and to create arrays of different dimensions, and it can produce a very high graphic. So S+, as I said, was originally installed in November 2010 by TIPCO Incorporation, Software Incorporation in the United States, and it is very, very expensive. So it can work on Unix, on different platforms like Unix. It can work on Apple, it can work on Windows. Also, it can be defined as an iterative programming environment for data analysis and production of high-quality graphics. It is based on AT&T Bell Laboratory in the United States. So it is an extension of S program, because this is S+. So it is an extension of S programming language. So what are we to do here now? So we're here to talk about the function, how to use this S+ in resampling methods. So number one is that this S+, the software has many menus. It has many menus. So the software has many menus and it has many functions, like for example numerical operators. We have the plus, we have the minus, we have divide, then we have the multiplication sign, we have the modulus. So all these are programming numerical. It's all these ones are also in C++ and in Java programming too, and it is used in S+. So you can, in S+, these are some of the symbols that can be found in S+, too. You have the column, we have the row. That is if you want to find a matrix. If you want to use arrays, in arrays you have something like this. So you A11, A12, A13, A21, A22, A23, A31, A33. So it can be used. This is the row, while this is the column. So this is a 3 by 3 array, a 3 by 3 matrix. So what we are now saying is that the issue is, I've talked about S++ now. So we now want to talk about why does bootstrapping work. The problem now is that bootstrapping does not come to erase the parametric and the non-parametric statistics, but it's here to make more improvements on the use of both parametric and non-parametric statistics. Like for example, it is assumed in statistics that if you know your population, then you take sample from your population, and the sample is a true representation of your population, which means that you can make inference from the sample. You can make inference from this. If you don't know the population, you can make inference from the sample. If you know the sample, you can make inference from the population. What I mean is that, let's assume we want to calculate the standard error. Standard error is equals to S over square root of n, where S is the sample variance, sample standard deviation rather, sample standard deviation. So this one is the number of samples. So if we want to calculate, this is population variance, population standard deviation, population standard. So if we don't know this, we can assume this is equals to this, because we got this sample from the population. If we take sample from the population, we want to make calculation about standard error, and we don't know this. Let's assume we want to calculate SE equals to 1 root n. So we don't know this, but we know this. We can use this in place of this, because the sample is a representation of the population. So that is number one. So number two is that we can say in a nutshell that to estimate a parameter in statistics, the quantity which describes the population, the use of statistics is corresponding to the quantity for the sample, which means that sample sometimes may be equal to the population. So that is all we want to present on S plus, and why does statistics work. So the use of sample to represent population is one of the reasons why we use bootstrapping, because bootstrapping has come to reinvigorate, to make better the use of non-parametric and parametric methods. Is not here to eliminate them, is to make them better and not to eliminate them. So that is all.
Okay, there are several uses of S plus software. First is for statistical research.
I think that S plus software also can use for data analysis.
I think to produce very high quality graphic. Sampling distribution is the distribution of a sample statistic. While the concept of distribution of a set of number is intuitive for most students, the concept of a distribution of a set of statistics is not. For example, from population, we can get sample mean, X bar. We sampling again from population, after that you can get sampling distribution. Bootstrap distribution is the distribution of many bootstrap statistics. For example, from population, we take one simple random sample. From simple random sample, we do again until finish, and then you can get this bootstrap distribution.
From the handout given by Dr. Bidin, we can see that the example 18.1, what do you all understand about bootstrap distribution according to the shape, center and spread?
Okay, the shape of the bootstrap distribution is actually nearly to normal. Okay, according to the central limit theorem, we can say that if n is large enough, so the sample distribution will be approximately normal. Okay.
For the center, the bootstrap distribution center is close to the mean of the original sample. So X bar is an unbiased estimate of the mean of the population. How about you, Raji?
So for the spread, we get more precise idea by computing the standard deviation of the bootstrap distribution. And also, if we apply the bootstrap idea, then we can use the standard deviation to estimate the standard deviation of the sample distribution of the X bar, which is the sample mean. So that's all.
So, in conclusion, resampling methods consist of many methods, including the bootstrapping and permutation test and many more. But here we just focus on the bootstrapping part. So bootstrapping is all about taking a sample from the population and keep resample for the original sample with replacement. So why we need to use the bootstrap? We need to use the bootstrap because when the assumption of parametric does not match, then it is easily performed. Lastly, bootstrap can answer non-parametric and parametric statistics that cannot be solved. So how about you, Raji?
Okay. In addition to what my friend Anga just said about the conclusion, there are basically 4 types of resampling methods. We have the Monte Carlo simulation, which uses proportion from a population. We have the randomization, which is otherwise known as the permutation test. Both randomization or the permutation test and Monte Carlo simulation make use of the exact p-values. So they use the exact p-values to compare to that of the samples. And the third one is bootstrapping, which we are more concerned about in this video presentation. It is the mostly used type of resampling method in the world, and it is done with replacement of the samples. It is used in calculating the confidence interval, in testing for the hypothesis, and the sample drawn from the population must be a true representation of the population, which means we can make conclusion, we can make inferences from the sample to represent that of the population. And the last one is the jackknife, which is used to estimate bias and standard error in a statistic. A statistic is a sample, is something like a sample, is different from the parameter, which is from population. Also, I would like to make mention of the flow of information in resampling techniques. Number 1 is we have to input the data. After inputting the data, number 2 is resampling from the inputted data. Number 3 is to calculate the test statistic. For example, if we have the t-test, then we have x bar minus mu over the standard deviation over the square root of the number of samples. Then we calculate the test statistic. Number 4 is to record the test statistic we have calculated. Number 5 is to return the sample for x number of resamples. We take the resamples, then we find we name it x. Then number 6 is to calculate the p-value. If we calculate the p-value, then we can use it to compare with the significance level, that is alpha. If p is less than alpha, then we reject the null hypothesis, which means that the alternative hypothesis is the default winner, and vice versa. Then we present, the final step is we present and print the results. So in a nutshell, p-value is compared to alpha, while the test statistic is compared to the critical values which are obtained from the table. So that is my friend has mentioned about the advantages of bootstrapping and all the rest. So that's all we have for this presentation. Thank you very much.